This video is a review of solving quadratics. So remember, when you are solving quadratics, you are looking for solutions, which you could also hear referred to as roots, zeros, or x-intercepts. The big part about that is you are basically looking for the place where your graph is going to cross the x-axis. So if I were looking at this particular graph, I would see that my quadratic cross the x-axis at two places, once right here and once right here. So the solutions for this would be at x equals -1 and x equals -6. I can also rewrite these so that they are written as coordinates. So because they're x-intercepts, this answer would be -1, 0. And this one would be -6, 0. So remember, I can either see it as x equals -1, x equals -6, or as -1, 0, -6, 0. Sometimes, though, we're not given the graph, and we have to get our x-intercepts from either the factored form of the quadratic or from just the quadratic written out. So this is an example of when we have to find the x-intercepts and we have it already factored for us. So if it's already factored for us, what we have to do is take the factors and we have to set them equal to 0. And the reason that we're setting them equal to 0 is because if you notice how this one is written, we've got our two sets of parentheses and it's equal to 0. These two sets of parentheses are not separated by anything, which means that they're being multiplied. Now, the only way that I can multiply two things and get 0 is if one or both of my sets of parentheses are equal to 0. So what that means is either 0 times some number, it doesn't matter what number, equals 0, or 0 times 0 equals 0. So what we're going to do is we're going to try to solve and figure out what values for x, when we plug them in, will give us 0 for this set of parentheses and this set of parentheses. So if I needed to solve something like x plus 1 equals 0, I would start by subtracting 1 from each side so that I can get the x to be by itself. Some of you may circle and jump that positive 1 to the other side and make it -1, but both of those just mean the same thing. So if I subtract 1 from both sides, this will cancel and I'll get x equals -1. For x minus 5 equals 0, I would either circle and jump that -5 to the other side and make it +5, or I could add 5 to both sides. And when you add 5 to both sides, the -5, +5 will cancel, which will leave you with x on the left side, and 0 plus 5 gives you 5 on the right side. So I have x equals -1 and x equals 5, or I could rewrite it so that it looks like a coordinate, or that they both look like a coordinate, which would be -1, 0 and +5, 0. So remember, I can either have it x equals or written as coordinates. Either way is perfectly fine. Find the solutions for x squared plus 7x plus 15 equals 5. So to begin with, your quadratic always has to be equal to 0 in order for you to be able to figure out what your solutions are, or what your x-intercepts or your roots or your zeros or whatever the problem is asking for. Remember that all of those mean the exact same thing. So this one's asking us to find the solutions, and anytime I'm trying to do that, I'm going to always make sure that it's equal to 0. So to start this one, I'm going to make this 5 move to the other side. So I can either circle and jump it and make it a -5 when it moves over, or I can subtract 5 from both sides. So if I subtract 5 from both sides, that's going to give me x squared plus 7x, positive 15 minus 5 would give you positive 10. And then it would be equal to 0 because those would cancel. So at this point, I need to be able to factor it so that I can get my two sets of parentheses and have them equal to 0, like we saw in the second example. So in order for me to factor anything that looks like x squared plus 7x plus 10, I have to factor it with the star method because this is an example of quadratic. And so we reviewed the star method yesterday. The first thing you have to do is you've got to, once you make sure it's equal to 0, label your a, b, and c. So remember, a is in front of x squared, which in this case would be a positive 1. B is in front of x, which is going to be a positive 7. And c is going to be your constant, which is 10. Once you do that, then you can label your star. So when you label your star, you got ax, a times c, ax, question mark, b, and question mark, and then you can fill in your numbers based on what you had for your problem. So ax is going to be 1x, so 1x is on the side. In the middle, you'll have 1 times 10, which is 10, and at the bottom, you'll have 7. So then you're looking for two numbers that will multiply to give you 10, but then you can add to give you 7. So if you think about 10, you could do 1 times 10, or 2 times 5. If you were to add 1 plus 10, you would get 11. And if you were to add 2 plus 5, you would get 7. Because we needed to add to give us 7, we're going to go with 2 and 5. So then we treat the sides as if they're fractions, so 1 over 2, 1 over 5. See if you can reduce. If you can't, you circle it. And your answer would be x plus 2 times x plus 5. But remember, if it was equal to 0 to start with, it's got to be equal to 0 whenever you factor it. This, however, is not it. At this point, we have to take each one of our sets of parentheses, and we have to set them equal to 0 so that we can solve and figure out what our x values would be. So if we've got x plus 2 equals 0, we've got to get rid of this plus 2, so we can either circle and jump it, making a negative 2, or we can subtract 2 from both sides. So whenever we do that, we get x equals 0 minus 2, which is negative 2. For x plus 5 equals 0, we can either circle this positive 5, jump it over, and make it a negative 5, or we can subtract 5 from both sides. And so when we do that, we get x equals 0 minus 5, which is negative 5. So we've got x equals negative 2 and x equals negative 5. Or if you wanted to write that as coordinates, you would have negative 2, 0, and negative 5, 0. What are the zeros for 7x squared minus 14x equals negative 7? So remember that you always want to have, whenever you're working these out, you want to have it equal to 0 if it's got 3 parts. So if we get it equal to 0, that means that we would have to take this negative 7, move it over. So we would either circle and jump the negative 7, make it a positive 7 on the other side, or we would add 7. Now, if we add 7, we'll notice that the negative 7, positive 7 will cancel, and that will give us 0 over here. But if we look, this 7 does not have an x or an x squared, which means that it is not a like term to either one of those terms, which means it's going to be 7x squared minus 14x plus 7. So now that we've got it equal to 0, we can identify what our a, b, and c are. So our a is going to be the coefficient for x squared, which in this case is 7. The b is going to be the coefficient for the x term, which is negative 14. And the c is your constant, which is 7. So then we draw our star, and we label our star ax, a times c, ax, question mark, b, and question mark. Fill in our a, b's, and c's from what we got from our problem. So we're going to have 7x and 7x, 7 times 7, which is 49, and then negative 14 for b. So when we think about 49, 1 times 49 would work, 7 times 7 would work. Because I need it to be a positive 49, but I need it to add to give me a negative 14, I'm going to need both of my terms to be negative, because the only way I can multiply to get a positive is either 2 positives or 2 negatives. But the only way I can ever add to get a negative, I would have to have some negatives. I can't ever add 2 positives and get a negative. So the only one that will add to give me negative 14 would be negative 7 and negative 7. So I'll put negative 7 here and negative 7 here. At this point, I say if I can reduce, so if I've got 7x over negative 7, I can divide the top and the bottom both by 7, which is going to give me 1x over negative 1. On the other side, I would reduce by the same thing. So if I divide both of the top and the bottom by 7, I'll get 1x over negative 1. Now, because I reduced both sides by the same number, that number has to go on the outside of my set of parentheses. So you know I always have the two sets of parentheses. This time, because I divided both sides by 7, I'm going to have a 7 out front. So then in my parentheses, I'm going to have x minus 1 and x minus 1, and it's still equal to 0 because I made it equal to 0 to begin with. So now I'm going to take each one of my factors and set it equal to 0. If I do 7 equals 0, that is not true, so I don't really have to worry about this one. But I do have to worry about my parentheses. X minus 1 equals 0, x minus 1 equals 0. So I will add 1 to both sides or circle and jump the negative 1. And whenever I do that, I would get x equals positive 1. But I noticed that I would do the same exact thing here and get x equals positive 1. I don't have two x equals positive 1s. I'm really only going to have one answer, so my answer is just x equals positive 1. I could also have that written as a coordinate, so it would be 1, 0. If I come out and only get one solution, that means that if this was my x-axis, and that's my y-axis, and I only have one solution, that means it's just going to touch at x equals positive 1. So my graph would look something like this. Our last example says, solve the following quadratic using the square root method. So on the last couple of examples, we've used the star method. Now we're going to move into the square root method. So we recently talked about the square root method in class. The square root method just means that you are going to have on one side an x squared term and on the other side a constant. And your job is to try to get rid of the squared. So to begin with, I've got negative 5x squared equals negative 20. I need to get rid of this negative 5 to start with because my goal is to eventually try to get x to be by itself. So to get rid of that negative 5, because negative 5 is being multiplied by x squared, I'm going to do the opposite of multiply, which is divide. So both sides are going to get divided by negative 5. The negative 5 and negative 5 will cancel, which will give me x squared equals, and then negative 20 divided by negative 5, which is positive 4. At this point, I'm going to get rid of the squared. To get rid of a squared, I'm going to do a square root. So I square root both sides. Remember that a squared and a square root are the opposite of each other, so they cancel each other out, which is going to give me x equals. But if I take the square root of both sides, I have to have two answers, one positive, one negative. Then I think about square root of 4. 4 is a perfect square, which means that there's a number that I can multiply by itself to give me 4, and that number is 2. So I have two answers. I have x equals positive 2, and I have x equals negative 2. The reason that I also have the negative answer is because if I think about two numbers that I will multiply together to get 4, the first one that you think about is probably 2 times 2. But remember that you can also multiply negative 2 times negative 2 to get 4, because a negative times a negative always gives you a positive, and then of course 2 times 2 always gives you 4. So your two answers would be x equals 2 and x equals negative 2, or you could write those as coordinates, so 2, 0 and negative 2, 0.